Okay, and you're welcome to our class on chemistry. So we will be studying a topic today, a basic and foundational topic in chemistry called nature of matter. So we'll consider some things: what matter is, what matter is made up of, how matter can be classified in some general ways. Then we also consider the states of matter today. So we just start right away, and also with the help of the details on the screen by going into what is matter. Now, as defined there, as shown there, matter is anything that has mass and occupies space. Matter is anything that has mass and occupies space. Now we can see two things in bold there. The first thing there is mass, and the second thing is occupies space. So those are the conditions that a thing or a substance should possess for it to be classified as matter. Now with those definitions, we can see something. It means that everything around us, both the things we can see with our visible eyes and the things we cannot see with our visible eyes, or many things around us that we can see with our visible eyes, and the ones we cannot see with our visible eyes, are examples of matter. E.g., we have things like your books, your chairs, air, humans, etc. You can see some pictures of matter or examples of matter. You can see a basketball there. You can see a dies, you can see a table, you can see a balloon there. There are other things you can also see there. You can see a book, you can see an heavy duty vehicle tire, you can see an apple fruit, and then you can also see a cup. Now, these are examples of matter. Why are they examples of matter? Because they have mass and they occupy space. Now, the examples we show for there are things we can see with our visible eyes. There are also other things that are so small, so minute that we cannot see with our visible eyes. However, they have mass and they also occupy space. Because of those conditions, they are also matter. In the course of our studies in chemistry, we will see examples of such things that we may not see with our visible eyes, yet they have mass and they occupy space. So those are some examples of matter, and then you can just name every other thing you see around you. They are matter. Why are they matter? Because they have mass and they occupy space. Now, having said that, it's good we take note of something key. Now, what is that key thing we want to take note of? It is the statement we can see there, the next paragraph, which says matter is made up of tiny particles. So it means that if we get any substance, anything, and then we break it down, try to know what makes it up, we end up with what we call particles. Now, these particles, some of them are called atoms, some are called molecules, and some are called ions. Now, what does it mean? It means some examples of matter are made up of tiny particles called atoms. It means some examples of matter are made up of tiny particles called molecules. And then some examples of matter are made up of tiny particles called ions. As we go further, we'll see the difference between atoms, molecules, and ions. However, it's important for us to also know that some other examples of matter could be made up of atoms, molecules, and ions in combination. That is something we need to know. Again, in the course of our future studies, we'll get to see examples that are made up of a combination of atoms, molecules, and ions. Now, so having stated that, so it's good we have this in mind about the particle nature of matter. It's good we understand that when we see a substance, it's good we know that this substance is made up of tiny particles. It is not just existing in that form in which we see it. It is made up of tiny particles. And as stated, some of these tiny particles could be atoms, some could be molecules, some could be ions. And yet some substance could be made up of a combination of 2 or 3 of these kind of particles. I will move further to see something else. Now, how can we classify matter? Or how is matter classified? Now you can see the paragraph we have there. It says matter is classified into 2 general categories. Now, what are they? We have what we call pure substances. And in brackets, pure substances can be either elements or compounds. So it means some pure substances, some of them are elements, some are compounds. And the other general category in which we can classify matter is what we call impure substances. And impure substances, they are also called mixtures. So don't forget, we can classify matter in 2 general ways. We have pure substances and we have what? Impure substances. Pure substances, they are elements and compounds. Impure substances, they are mixtures. So in essence, instead of we just putting the fact that matter is classified into 2 general categories, we can also say, and which is very accurate, and you may see it a lot this way, we can also say that matter is classified into elements, compounds, and mixtures. I come again, matter can be classified into elements, compounds, and mixtures. But as stated some few seconds ago, elements and compounds are pure substances. So we are going to understand what we mean by pure substances as used in chemistry, not as used in everyday interaction with people. And then we're also going to understand what we mean by impure substances called mixtures as we go on. Now, let's go on to what we mean by pure substances. Now, what are pure substances as seen from the angle of chemistry? Pure substances are substances which are made up of only one type of particle. Only one type of particle. Now, when I say only one type of particle, I don't just mean that it must be atoms, or it must be molecules, or it must be ions. It can be molecules, it can be atoms, it can be ions, but the key thing is that the kind of particle that make up that substance, they are one type. So when we consider all the particles, because matter is a given matter is made up of numerous particles. So when we consider all the particles that make up that substance, they are of one type. If they are of one type, then that substance is a pure substance. That is, like we can see, as we can see there, they do not have particles of other substances mixed with them. They do not have particles of other substances mixed with them. We stated before now that the pure substances can be elements and they can be what? Compounds. So don't forget, when you hear the word pure substances, they are made up of just one type of particle. Now, if that pure substance is an element, it means that the element is made up of just one type of atom. Besides, elements are made up of one type of atom. That is why they are what? Pure substances. If it is a compound, then compound is made up of molecules. Molecules are combination of two or more atoms. Now, if it is a compound, then it is made of one type of molecule. That is what it means. So we're going to see some pictures, some images to communicate that idea more. And then what about impure substances called mixtures? They have particles of other substances mixed with them. That is why they are impure substances. Now let us see in form of diagram what we mean by pure substances and what we mean by impure substances. Now consider these pictures we can see here. We have tagged them A, B, and C and D. A, B, C, and D. Now you can see A. Now what can you see there? You can see the particles that make up substance A. They are of one type. One type. So because they are of one type, they are pure. And you can see them single spherical circles in green. They are of one type. Now what about substance B? You can see two particles of the same color joined together, and then they are spaced. So you see one set of two particles joined together, separated from another set of two particles joined together, and then separated from a third set of two particles joined together, and then a fourth and a fifth. But what can you notice about them? They are of one type also. Again, substance B is a pure substance. Now, what about substance C? What can you notice? You can see a set of three particles, of which one is red, joined by two blue particles. Now you can see four sets. Again, each of these sets are of one type. Now they are molecules, but they are of one type. Because they are of one type, that substance C is a pure substance. Now, what about substance D? Now, take note of substance D. We can see different types of particles. You can see two single particles far apart, but then they are red in color, spherical. You can see other particles that are also different. Now, because we have different types of particles in substance D, then substance D is an impure substance. So that is how we identify pure substances and impure substances. So by this, we can say that substance A, B, C are pure substances, but substance D is impure. Now, why is it impure? Because it is made up of more than one type of particle. And in substance D, some of the particles are atoms and some are different forms of molecules in substance D. Then let us see the definition of pure substance in chemistry. Now, how do we define pure substance in chemistry? So in chemistry, a pure substance is pure when it is made of only one type of particle, while a substance is impure when it is made of more than one type of particle. Now, having stated this, we can consider some general characteristics of pure substances. Now, come with me as we consider them together. Of course, some of these we have mentioned in the course of our studies thus far. Now, one of them is stated there. All the parts are the same throughout. Of course, that's what we mean by one type of particle. All the parts are the same throughout. That's one general characteristics of pure substance. So it means if we pick an element, all the parts are the same throughout. If we pick a compound, all the parts are also the same throughout. The B part says their composition is definite. They have a definite composition. The C says they cannot be easily separated by physical methods. That's one other thing about pure substances. They cannot be easily separated by physical methods. As we move on, we will get to understand what we mean by physical methods of separating substances. But then, if we are to separate a substance by physical method, then that substance has to be an impure substance, talking about mixtures. And then we have the D parts about pure substances. Pure substances, they have unique sets of physical properties, like melting point. So a pure substance will have a particular melting point or a small range of melting points. Example is ice. Ice has a melting point of 0 degrees Celsius if it is pure. Other physical properties they may have are boiling point, density, the physical state of the substance, and then we have also what is called spectroscopic properties. In the course of more studies in chemistry, as you follow our classes, you will get to understand what we also mean by each of these properties. Don't forget, a pure substance have unique sets of physical properties, and those properties, they are definite. And let's move on. So what we call the subheading there, properties of matter. So let's consider properties of matter. Now, we've been discussing matter thus far, so we want to see some properties matters can take up, or some ways we can identify or we can use to identify or describe a given matter. Now, we can see the properties of a substance tells us what a substance is, how it behaves, or how it responds to certain changes, or what it does. That is what we mean by the properties of a substance. Now, having this in mind about what property means, don't forget it tells us what a substance is, it tells us how a substance behaves, it tells us how a substance responds to changes, or what a substance does. These are some things about properties of a substance. But then, substances can have properties in two forms. We could have what is called the physical properties of substance, and we could have what is called the chemical properties of substance. In our study of chemistry, one thing we will always do is that we always talk about the properties of substances, the properties of matter, however the form the matter may take. When we are considering these properties, we will consider them from the angle of physical properties and from the angle of chemical properties. is very important we consider them from both angles, because these properties will make us know how this substance can be used, or what this substance is best used for, to make the existence of man easier on earth, and also to drive the economies of the world. Now, talking about physical properties, what do we mean when we are talking about the physical properties of a substance? So it's easy and simple. There are things we can relate with when we see the substance or when we perceive the substance. Now, by physical properties tells us what a substance is. When the constituents remain the same, that is to say, when these things that make up the substance remain the same. Now, there are properties we can identify with using our senses, or that we can measure using instruments and apparatus. The examples are the color of the substance. So when I see a substance and I see the color of that substance, I can tell, let's say the color is purple or pink. I can say one of the physical properties of this substance is that it is pinkish. So the color of the substance is a physical property of that substance. The odor of a substance, talking about how it smells, is a physical property of that substance. The taste of a substance is a physical property of that substance. The texture, hardness, melting point, boiling point, density, viscosity, solubility in water. What means solubility in water will mean whether it can dissolve in water or not, or the extent to which it can dissolve in water. That is what we mean by solubility in water. And then the physical state, whether it's in the solid state, in the liquid state, or in the gaseous states. When we mention any of these as shown on your screen, we are talking about the physical property of that substance. Don't forget what I said. These properties give us an idea of how the substance can be used. Do not forget that. It gives an idea of how the substance can be used. As we go on in our study of chemistry, we'll get to understand this better. Now, what about the chemical properties of substance? Now, when we're talking about the chemical properties of substance, the chemical properties shows the behavior of a substance. If or when it reacts, talking about when it combines in a chemical with another substance. When we use the word reacts in chemistry, we mean a substance is combining with another substance to form something new. That's the meaning of the word react. So another word for it could be chemical combination. When we say something reacts, it means it is combining in a chemical way with another substance. Now, what do we mean when we say something combines in a chemical way? It means that when they combine, they will form something new that is different from the individual substances that combines. Now, what are some of these chemical properties that we will get to see? When we're talking about chemical properties, some could be flammability, as seen there. Some could be what is called precipitation. Some could be what we call decomposition of a substance. And another example of chemical property is called the rusting of iron. As we go on again in our study of chemistry, we will see more details of these properties. And we will always talk about chemical properties. Why? Because it is these chemical properties that will determine how we can convert a substance to another form by combining it with another substance, such that what we get, the new substance we get, will meet the need of man in making life easier, and it will also drive the economy of the world, just like the beautiful things we see in the world today. Do not forget, chemical properties involve changes in the constituents of a substance. So what it means is that whenever there is a chemical property or whenever there is a chemical reaction, a substance will undergo change in its constituents. Keep that in mind. More details will be seen as we go on in our study of matter. Now, we'll go on to the states of matter and we'll consider some key things about the states of matter in this video. Now, what are the states of matter? We have three major states of matter. We have what is called the solid states, we have what is called the liquid states, and we have what is called the gaseous states. Now, there's something we need to understand. At the beginning, we said that matter is made up of tiny particles. Some could be atoms, some could be molecules, and some could be ions, talking about the particles that make up substance. Now, let me state this here. The different states of matter differ in the way the particles that make them up are arranged together. That is the major thing we need to know. The states of matter can be understood by how the particles in them are arranged. So there's a way the particles are arranged in the solid state, which differs from how they are arranged in the liquid state, and it differs from how they are arranged in the gaseous state. And you can see them stated there. So you can see the picture we have there. We can see pictures A, B, and C, or simple sketches A, B, and C. Their substances: A is a gas, B is a liquid, C is a solid. And what we see inside of them are the particles that make them up. Now you can see that the way the particles are in A differs from how they are in B. And then the one in B yet differs from how they are in C. This arrangement is what differentiates a solid substance from a liquid substance from a gaseous substance in terms of the particle arrangement. Now, let's consider some of them, some things that we get to see by the way the particles in these substances are arranged together. Now, in solids, the particles are packed up together. Of course, you can see that there. The particles are packed up together. So when we say they are packed up, it tells us that the space between them is very minute. The space between the particles is very small. They are packed up together. Now, why are they packed up? Why are they packed up together? Because they are held by strong forces of attraction. The result of this is that the particles do not move. They only vibrate about their main position. And again, because of the nature of the arrangement of these particles, they have fixed shapes, and they have what? Fixed volumes. There's something key that is stated there in the second sentence. It states that the particles do not move in solids, they only vibrate about their main position. Now, let me show you what we mean by vibrating about their main position for particles in the solid state. So you can see this. You can see this. You can see how the particles here, they are vibrating. They cannot move. Why? They are packed up together. They are held up by strong forces. The best that can happen is that they just keep vibrating about their main position, as shown by this short video we can see here. Now, this is how the particles in solids exercise motion. So the best form of motion they can get is called vibrational motion. They just vibrate about their fixed position. They cannot move from one location to another. Take notes, we are talking about the particles here, not the entire substance. For instance, the entire substance, we can move it from one place to another, but the particles in them will just be vibrating about their main position. They cannot move. That is one thing about particles in the solid state. It's good we take note of that. That is how they function. It's good we take note of particles in the solid state. That is how they are. Now, we move further and then we consider the particles in the liquid state. Now, what are the informations we need to get about them? What are some informations we need to get about the particles in the liquid state? Now, we'll go back to our notes. Now, in liquids, the particles are free to move. They can move, but then they cannot move. Why? The reason because they are not held by very strong forces that hold particles in a solid state together. They can move, they are free to move, but are not far apart. So they are apart from one another, but not far apart. Now, what this means is that they can move because of the space between them, and they can move to a certain extent, but their movement is not infinite. So they can move to a certain extent and then they stop, the particles. Now, why? Because they are still held by some forces of attraction. However, the forces that hold them together, they are not as strong as compared to that in the solid state. Now, because of the way the particles in liquids are arranged, they have definite shape. They do not have definite shape. Why? Because they take the shape of the container. So if the container is in the form of a cylinder, the liquid will take a cylindrical shape. If the container is in the form of a cone, the liquid will take the shape of a cone. If the container is in the form of a rectangle, the liquid will take the form of a rectangle. Don't forget, the particles, they are free to move, but not very far. Why? Because they are also held by some forces of attraction. Now let us see how the particles in liquid move. So let's see this, that will help us understand how the particles in the liquid, how they move. So let's see this short video on how the particles move. So you can see liquid particles here interacting with one another. They can move, but not very far. Why? Because they are still held by some forces of attraction. That is the idea for particles in liquid state. And let's consider the final state of matter, talking about the gaseous state of matter, talking about gases. Now, what is that we need to know about gases? Now, it's important we consider this about gases. Now, the first thing is that for gases, the particles are far apart. They are far apart, they can move very far. They are not restricted in their movements. Why is this so? Because the forces of attraction that holds them together, they are very weak. So they have very weak forces of attraction that are quite insignificant. Now, because the forces are so weak and insignificant, we can say the forces are negligible. So, due to the fact that the force that hold the particles in gas together, because the force is so weak, the particles can move non-stop. They are spaced out. They are far apart, as we can see in the picture above. The particles are far apart, they are spaced out, and they can move without restriction. Also, gases have no definite shape and they have no definite what? Volume. Why? They just move. The particles move in a random manner because the forces that hold them together the forces are very weak. Let us see the motion of particles in the gaseous state. Let's see the motion of particles in the gaseous state and understand how gaseous particles move. So we can understand how gaseous particles move. Now, in the gaseous state, we have the particles in this form as shown by the video we are seeing, the short video we are seeing. So you can see the particles here. Now, what can you notice? They just move in a random way. There is nothing restricting their movements. The forces that hold them together, they are so weak, and the particles can just move non-stop. So we see those examples in smoke particles, and we see them in perfumes. When perfumes are sprayed, the perfume can travel from one end of a house to another end. Why? Because those particles are gaseous. They are particles in the gaseous state, and because they are not held by very strong forces of attraction, the particles are free to move. So this is the form that the states of matter take. So far we've seen some things about matter. We've seen the definition of matter. We've seen the examples of matter. We've seen how we classify matter as pure substances and impure substances. And we mentioned that pure substances could be elements or compounds. We also saw some general properties of pure substances. We saw how we can talk the properties of matter, talking about the physical properties, the chemical properties, and we've also seen the states of matter. So I would advise you study this material more for better understanding and to get out of that textbook. You join us for the next video, which will be posted soon.